video we're going to take a look at molarity and how do we go to and from molarity when we're dealing with grams. So first things first, you have to understand that molarity is the number of moles in 1 litre. So I have molarity is equal to moles per litre, meaning divide by litres. So you must remember that. So if I'm going to put together the molarity of this, I need to know 2 things. I need to know the number of moles that I have, and I need to know the number of litres. I already have the litres. It's given in the question. So that's nothing too difficult. It's actually just 1 litre. And what I have to do then is find the moles. So that's actually the first half of the question here, is work out the moles. I'm not given moles, I'm given the grams. So then my brain needs to go and think, what is the connection between grams and moles? And you should immediately go to molar mass. So I'm going to look at what I have, which is sodium carbonate, Na2CO3, something you'll be very familiar with from the titrations. That sodium carbonate, we're going to work out the molar mass. So sodium carbonate is going to be 2 by sodiums. There's 2 of them, so we're going to have 2 by Na plus 1 by carbon plus 3 by oxygen. And I'm going to fill in from the periodic table what are their masses. So Na is 23 plus 1 by C, so 1 by 12 plus 3 by O, which is oxygen, so 3 by 16. And if you put all of that into your calculator and tidy it up, you will get 106. And remember, the units from the periodic table is grams per mole. So 106 grams per mole is what we're working with. That's the molar mass. How do I use that to convert grams into moles? Okay, if I want to go into moles, I need this fraction. So I'm actually going to write it out differently. 106 grams over 1 mole, because that's what it means. It's 106 grams in 1 mole's worth. I actually want the moles to be on top. I do not want the moles to be on the bottom. So what I'm going to do is I'm going to flip that fraction around. You can do that. You can get the reciprocal of it. So it's going to be 1 mole per 106 grams. How does that combine with what I have then? Well, let's take a look. I have 4.783 grams according to the question. And what I'm going to do is I'm going to multiply it by 1 mole all over 106 grams. So what's happening here is I'm going to be multiplying top by top, bottom by bottom, like it's a fraction. It is a fraction. And then I'm going to find that the grams actually drop out for us. So that was the goal. The only unit I have left now is the moles. That's all that I have left, which is what I wanted, because I was missing that piece of the puzzle for the molarity. So I'm going to go 4.783 divided by 106, and what I'm going to get from that is 0.541. So I'm going to take, so that's 0.0451. I'm going to take that now. That is my mole, so I should write out for myself the units so that I'm clear about where things are going. That is the moles part of what I was missing for molarity. So remember, molarity is moles per litre. Keep saying that in your head. Molarity is moles per litre. I'm now going to fill it in. It's 0.0451 and it's divided by 1 litre. So I've got a molarity of 0.0451, and it's capital M for molarity. So that's all that you had to do. So think about, what do I have, what do I need, what is it that they're asking me for? They asked me for molarity. What is molarity? Moles per litre. What do I have already that allows me to fill into that? I already had litres. There it is. I highlighted it in yellow. The next thing I needed to look at was, do I have moles? I don't, but do I have a connection between moles? I do. I have the grams, and I know that molar mass can be used to convert grams into moles. If you really hate that, and you really don't like dimensional analysis, then you can learn off a triangle for yourselves. So the triangle is going to be, on the top you have your mass, On the bottom, you're going to have moles, and on the other side, you're going to have molar mass. And it works just like that stupid triangle that you learnt in junior cycle. You cover up what you want, and then it'll tell you what you need to do. So in that case, we needed to find moles. Look at what's left. It's going to be mass divided by molar mass, which is actually what I did here, because I flipped it and I multiplied. And if you reverse that, flipping it and multiplying is the same as dividing. So if you'd rather, that's the triangle that you need to take down. So pause and write it down for yourself and try it with the next question that I'm going to bring up. So the next question that I have here is, what is the molarity of a solution containing 5 grams of NaOH? So NaOH is something that you'll be familiar with from the titrations as well. NaOH is sodium hydroxide. So we're looking at dissolving 5 grams of that in 750 milliliters. So remember, we want concentration, we want molarity. First thing I'm going to write down for myself is that molarity is equal to, you should be able to recall it at this stage, moles per liter, and keep saying that definition over and over again, moles per liter. Do I have any of those? Well, I have a measurement for the volume, right? But in this case, the volume isn't in liters, it's in milliliters. But if you've watched my other videos, you will know that for the milliliters, you can very quickly change it into liters by saying multiply by 10 to the minus 3. So that is 750 by 10 to the minus 3 liters. And in the end, when you're plugging it all into your calculator, you just write that. So you don't have to stress about dividing by 1,000. All I did was I replaced the word milli with what it actually is mathematically, which is 10 to the minus 3. I now have to work out moles. So I go back to the question, is there anything in the question that allows me to make a connection to moles? And there is actually. We've got the 5 grams here. And the 5 grams, how do I go from grams into moles? Well, you can use this if you like. I have grams and I want to get to moles, so we cover up the moles part, and what it tells me to do is it's mass all over molar mass. So let's get that out. So I actually first have to get the molar mass of NaOH. So molar mass is going to be sodium by 1, so 1 sodium plus 1 oxygen plus 1 hydrogen. And I'm going to have 23 for our sodium. So 1 by 23 plus 1 by 16 plus 1 by 1. And if I tidy that out, I'm going to get 23 plus 16 plus 1. And if I do that out, I'm going to get 40. So I get 40, and remember the unit from the periodic table is grams per mole. And then if I use this method, remember I'm covering up moles because that's what I want. It tells me to take the mass, which is 5 grams, and they say divide it by the molar mass. So if I divide it by 40 grams per mole, according to this, I'm left with moles. So then I just have to put into my calculator 5 divided by 40, and I get 0.125 moles. Now remember, we had our liters earlier on, that went there. The moles goes on top of the molarity. So remember, molarity is moles per liter. So I now have that, it gets fed in here. Now there's an extra step in it this time because I'm not dissolving it into 1 liter, so it didn't just drop out straight away. So I actually just have to put it into my calculator, that's all. So in my calculator I put in 0.125 and I put in divided by 750 by 10 to the minus 3. So I'm putting just the fraction into my calculator as I have it on the page there, and when I put it into my calculator I get 0.16, and it's 16 recurring, so it's 167, and it's a capital M for molarity. So all you have to do is keep going back to the definition of molarity. It's the number of moles per litre, and then if you like, you can use that triangle to convert between your grams and your moles. But as I advised previously, I think it's better if you can learn to use the units, because that's applicable right across the board through all of your STEM subjects, not just in chemistry. So to do one more example then, let's take a look at this one. So it says, what weight in grams? So now we're looking for grams, and we're being given the molarity in this case. So I want to figure out, okay, if I have molarity, which is moles per litre, and I know what the litres was, how could I get out the grams? So let's start with what we know. We know molarity, and remember, start with the definition of molarity. It's moles per litre. But what I know I have is I've got 0.5 moles in 1 litre. But do I have 1 litre in this case? I actually don't. I've 2.5. So if in 1 litre I had 0.5, how many moles do I have in 2.5 litres? Well, stop and think about it for a second. If I had 2 litres worth, I would have double it. If I have 2.5, I'm going to have 2.5 times it. So I'm going to go 0.5 multiplied by 2.5. And so I'll write that down first. I have 0.5 moles divided by 1 litre multiplied by 2.5 litres. And again, look, the units can guide you here. You wanted to just get moles on its own, no longer have litres on the bottom. If you multiply by litres, it'll drop out. And if you multiply this out, it tells me that I have 1.25 moles of the substance. So in a 2.5 litre bottle of our KCl here, or potassium chloride solution, we have 1.25 moles worth of it in there. Now, they didn't want us to get moles, they wanted us to get grams. So now we're going back to our connection between moles and grams. So we go to the triangle, or you can use your units if you like. If I go to the triangle, remember up the top is mass, which is grams. On the bottom, you've got moles. And over here, we've got molar mass. And this time, what I'm looking for is the weight in grams, in other words, the mass. So if I cover up mass here, it's telling me it's moles, and this is multiplied by molar mass. So I'm going to first have to find molar mass. So hopefully you're finding that, and you're spotting that in this, what's really important is you're learning that molar mass is something that you're always going to have to calculate, and you have to get really, really good at that. So potassium chloride then. So for potassium, I have a weight of 40. So let me write out what I have first. So the formula is KCl. I'm going to have 1 by potassium plus 1 by chlorine. Chlorine is one of the ones that it's so close to the 35.5. We actually don't round it up to 36. We will take it as 35.5. And potassium, I said a minute ago, was 39. Sorry, so it's 39. So 1 by 39. And if I do that in my calculator, I'm going to have 39 plus 35.5. And if I get that out, I get 74.5. And remember, the units for molar mass is the grams in 1 mole. And the question was for us to get out what the moles was. How do I do that? Remember, if you use the triangle, it's going to be moles by molar mass. Or if you think about it, and think about the units that you're using, how would I get rid of the moles? Well, if you treat it like you do your algebraic equations, you'd need to multiply by moles. And if we go back up, the number of moles was 1.25. So this is what I have. So if I multiply that out then, 74.5 multiplied by 1.25, what I get out is 93.125 grams. So that's how many grams I had in the 2.5 molar solution of potassium chloride.